Outliers affect the least square regression line. The first thing I would like you to do is there's a link in Canvas that will take you to this applet. So if you go to today's date in your module, follow the link for this so you can follow along. So what we're going to do is we're going to use our applet to go through our activity. So we're going to click on the graphing area and add 10 points in the lower left-hand corner. So the correlation is about 0.40, and I'm reading right off your worksheet here. So here's our graphing area in the lower left-hand corner. I want you to do your own. So pause the video and just down in here add 10 dots, and you want to make them be as close to 0.40 as you can, but let me show you. You can move an individual dot around and change the correlation. So get your dots on and then move them to get as close to 0.400 as you can. And once you've done that, restart the video. Alright, so I added my 10 points and I actually got my correlation to be exactly 0.4000 by dragging some lines around. So I've sketched it below. I've sketched in my least square regression line, and I had clicked the box that showed me where X bar and Y bar were, and I put those in also so we could see them. So if you haven't done so for your plot, go ahead and do that now. Alright, so let's take a look. Here's my correlation. It's at 0.400. So what we want to do is, according to A, we want to add a point that is on the far right side of the graph on the horizontal line for the mean of Y. So here's our mean of Y. So we want to go far to the right. We want to add a point on there. And I want you to pay attention. So before we start, look at your Y-intercept, look at your slope, and look at your correlation coefficient. So I'm going to come out here. I'm going to click. Okay. When I clicked here, the line came down. When this came down, the left-hand end over here came up. So what happened is my slope decreased because it went flatter. Okay. My Y-intercept, because the right end came down, so the left end went up. So my Y-intercept increased. And my correlation, so what happened to the correlation? It's now 0.3036. So my correlation decreased. Okay, so, and I'm going to go ahead and label that point on my graph. I'm going to label that point A because it went with A for my answer. So go ahead and try B and C and D all on your own with your graph, and then I'm going to talk through on it on my graph, but we should see similar results. Pay special attention. Does the line get steeper or less steep, or does it change at all? What happens to the Y-intercept, and what happens to your correlation? Pause the video and come back when you're done. Alright, so let's see how you did. You should have a very similar result. So if a point is added on the far left side of the graph on the horizontal line for Y, for the mean of Y. So here on the left-hand side of the graph, I added my B dot. And when I did that, the Y-intercept got pulled towards the B dot. So the Y-intercept decreased. So when this end of the line, when the left end went up, that made the right end go down. So the slope of my line decreased. And my correlation coefficient, when I looked at it, became, this was my correlation coefficient. Yours would be different, but it should have decreased also. So now, and for C, we added a point below the least square regression line on the vertical line for the mean of X. So here's my C dot right there. And what happened is, if you watch, what happens is the whole line gets shifted down. The Y-intercept did not, the line did not tilt, it just got pulled down. So my Y-intercept actually decreased when I did that. my correlation went down to 0.2343, so it decreased, but your slope of the line is really the same. It just shifted down to account for that, but it did not change the slope because it's on the balance point here, so it didn't change the slope. And then if we look at D, I put my D dot up here on the line for X bar. Okay, so D has a similar effect that C did. It moved the whole graph up, but my slope stayed the same. But because the whole graph went up, the Y-intercept increased, and then my correlation went down to 0.1588, so my correlation decreased. So let's kind of summarize this a little bit to give us some information. So I'm going to turn this sideways so we have some room for some notes here. So for A and B, so right here I'm talking about A and B. What if you add a point on the horizontal line for Y bar, so left or right, what you're going to do is you're going to tilt the line. Okay. From that point X bar, the mean of X and the mean of Y, which is right there, the mean of X and the mean of Y. This point acts like a balance. So when you added this point here, it dragged this side down, but here's your balance point, and the opposite side went up. Okay, so it acts like a seesaw. Okay, so if you had your line, you have the balance point at X bar, Y bar. Okay, so that kind of helps you think about what would happen. You put a point above this, this is going to pull the line up, which makes the opposite end go down. Okay, so they have an inverse relationship because it's a stiff board. Okay, and it's going to seesaw back and forth. For C and D, we did different. We put above or below on the X bar line. Okay, and what that does is it lifts or pulls down your line from X bar, Y bar. So it's either going to lift if it's above or pull down if it's below from X bar, Y bar. And it creates large residuals. Remember, errors from the line. You're going to end up with large residuals there. So it's not tilting in any way because it is on the balance point. It's right in the middle. So it's not weighting one way or the other to create a tilt. It just pulls the graph up or it pulls the graph down, depending on where you put your line. Okay, and so that's what we were seeing when we added this stuff in. Now, question 3 is which outliers had the greatest impact on the least square regression line? Vertical, which is your up and down, or your horizontal? Actually, your vertical didn't change your slope, and the only reason the Y-intercept changed is because the whole bar went up and down, and your correlation decreased because you placed points outside of the pattern, so that's going to make your correlation decrease. So really, your horizontal had more of an impact because it changed everything, all 3 items, not just 2 of them. Horizontal, they have more leverage. Since they are left or right of the balance point. So when they're left or right, they create more of a change. If they're up or down, they create less of a change from the X bar, Y bar, okay, from this balance point. So let's flip this over. I have some summary stuff to tell you. And there are 2 things. And we can kind of like we just almost half and half, but not quite. So we have our scatter plot, okay? On your scatter plot, you can have some data. Your least square regression line, as your calculator would calculate it, will give you the very best one. Should go kind of right through the middle of it. Then you're going to have, remember I told you the least square regression line always goes through the point x bar, y bar, the mean. So, and this is for showing you kind of how the balance is. This isn't really something that shows up on your calculator, okay? So this is your x bar, this is your y bar. And remember that this is your balance point. That if you go left or right, you get a seesaw effect. Okay? If you go above or below on that center point, all it's going to do is shift it up and down. So if you go above and right, you're still having a seesaw effect. The only time it's not going to change your slope is when it's right on your x bar. Okay? So a good least square regression line is going to have a low S. Now remember, S is the standard deviation of the residuals, and it's going to have a high R squared, which is how well does it predict. Okay? Now, sometimes they don't give you the data to create your least square regression lines. Sometimes they only give you the summary statistics, and they want you to create this line from the summary statistics. So we have the least square regression line. Remember, that's your y hat equals a plus bx, where a is your y-intercept and b is your slope. Okay. Now, this is going to be from your formula sheet. So I want to show you your formula sheet here. And we're going to use these two formulas right here to write the equation on the line when you don't have the actual data, when they only give you the summary statistics. So use for summary statistics. Okay, so let's see. We have defined your slope. From summary statistics, you're going to take the correlation coefficient and multiply it to the standard deviation of the residuals for y divided by the standard deviation of the residuals for x, and that will give you your y-intercept. Okay? And then to find your a value, you're going to use this other formula. Y bar equals a plus bx. You're going to substitute in the b you find right here, in for b here. You'll know y bar because it will be part of the summary statistics, so you'll plug it in, and this is x bar, and you'll have x bar from your summary statistics, and you're going to solve for a. Then you'll have a and b, so you would take a and b and plug into your formula. And then you'll have the equation of the line. So you're going to get a chance to do this right here. What I want you to do is to answer these three questions. And the last one is, be sure you read this. All your summary statistics are in here that you're going to need. But one thing you have to know is your copy is not in color, and it refers to these points. So I want you to this very far right point, right there, circle it. That's LA. It's the Los Angeles Dodgers. And then this point right here, that's Cleveland Indians. So you're going to explain what those points do to the graph, and then you're going to use this information to write the formula of the line without having the data to input to your calculator. Pause the video and check your answers. All right, before I show you the answers to the check your understanding, I wanted to just make special attention to the fact that every one of the points that we put in here were really outside of the pattern. And that's important because outside of the pattern points have more of effect than something in pattern, outside of the pattern. Because we were specific when we talked about adding it to the Y-bar line, so it's taking it more out of the pattern than if we had put it out here on this side. Same over here, in pattern would have been down over here, and we were asking for a different spot than in pattern. And then obviously the above and below were very much out of pattern. So I want to make sure you are thinking about when we talked about what happens when you have points outside the pattern. We know that our correlation is going to decrease, and then this is going to help you think about what happens. Usually you've got a teeter-totter effect because you're going left and right. If it's right on the mean above and below, then it's just going to rise up and rise down. So, all right. So here's your answers. Take a look. So what influence does the Los Angeles Dodgers have on the regression line? And you have to explain your reasoning. So since LA is to the far right and below the least square regression line, the Y-intercept, because we have a balance point here, the Y-intercept will increase because the slope decreases. This is going to pull this line down, and when the right side gets pulled down, the left side shifts up. So your Y-intercept increased and your slope decreased. All right, and then describe the influence of the point of the Cleveland Indians has on the standard deviation of the residuals and R squared. So remember, the residual is the error between from here to here. That's your residual. Cleveland is above, so he has really this large residual. Look at LA, he does not have a very big residual. Cleveland has a big residual because he's outside of the pattern and has a big residual. The standard deviation of the residuals is going to increase because he's got such a large error. And when your standard deviation increases, your correlation is going to decrease. And when your correlation decreases, your R squared also decreases because R squared is literally the square of your correlation. So once correlation goes down, your R squared is going to go down. And so that means this line is less effective at making predictions than it could be. Okay. And our second question, was we had a whole bunch of summary statistics. We had X bar and the standard deviation of the residuals for X, and we had Y bar and the standard deviation of the residuals for Y, and then we had a correlation coefficient between them. So to find the least square regression line, we could find our our slope by taking our correlation times the standard deviation of the residuals for Y divided by the standard deviation of the residuals for X, and I got 2.75. To find my Y-intercept, I had to use this, and remember this is on your formula sheet, what Y bar equals A plus BX bar. And I plugged in all the numbers that I had. Y bar was up here in the 171.43 equals A is what we're looking for. 2.75 is the B, we just found that. And X bar is right here in our story. Plugged everybody in, solved for A, and I got 103.34. And your final step is to plug it into the equation, and now you have your least square regression line, and you could make predictions off of this if you wanted to. Hopefully that was helpful. Let me know you have any questions, and I'll see you in class.